In this video, we're going to walk through setting up the automatic parts loader on this ST15Y turning center. The new APL interface offers step-by-step guidance through the entire setup process. So even a novice machinist or operator should be able to get set up and have the APL loading their parts right away. And we think you'll find the setup process becomes familiar quickly once you've had a chance to use it. The APL includes 3 sheet metal templates for locating groups of round slugs on the table. Each one of them has a different part size range and part count capacity. Changing these to match the raw stock you're working with is easy. We use dowel pins to locate the template and a cap screw to secure it in place. Since the slug diameter we'll be using here is 3 inches, we're using the medium range template, and it's adjusted so there is about an 1/8 inch gap on all sides of the part. You can find lots of useful information about templates, part grippers, layout dimensions, bar templates, and APL part size and weight capacities in the 5-page machine layout drawing found on the APL main page at haascnc.com. In this document, you can also find a chart that provides the location for each gripper finger depending on the part size. All right, let's set up our part. Since we're using this 3-inch diameter by 1-inch thick slug, let's look at a couple of things that we need to take care of before we start the APL setup in the control. First off, I've already positioned the fingers on gripper number 1 based on the locations provided on the APL layout drawing. This will depend on the diameter of the part. The material we're using is, of course, raw stock. Next up, I positioned the fingers on gripper number 2 to hold the finished part, again based on the layout drawing. A decision will need to be made here regarding the best diameter or feature to hold the part from when removing it from the chuck after machining. I've chosen to grip this smaller diameter here. Number 3, the part cutting program should be ready and in the control's memory in order to get started. Don't forget to put an M299 at the end of the program instead of an M30. This will activate the APL when it's in APL mode. Number 4, the chuck jaws for the job should be installed and machined as necessary. We recommend chamfering the jaws with a 45-degree angle for easier part loading. And last up, the chuck PSI should of course be adjusted to the desired grip pressure. When setting up the APL, there are 4 important reference positions that we need to teach the APL. Number 1 is the raw stock initial pickup location from the APL table. Number 2 is the chuck load position with gripper number 1. Number 3 is the chuck pickup position with gripper number 2. And number 4 is the table drop-off location of the machine part. There are a number of questions to answer along the way, but the Haas Control and APL interface will display images, text, and animations to make it clear what information the control needs. So let's get started. First, let's press the current commands key. Highlight the Devices tab and navigate to the Automatic Part Loader tab. There are 4 tabs under the main APL tab: Template, Load Part, Unload Part, and Run Job. The entire setup process consists of filling in all the required information on each of these tabs. We recommend going through them in order from left to right. Once you are familiar with each of these, you can navigate and fill in the information in any order you want, as the outcome will be the same. First off, we have the Template tab. The Template tab defines the table grid pattern and the part information. Before we start entering values, let's check out the pre-existing templates that we can load from memory. Arrow over to the Run Job tab on the right, and then press F4. This brings up the Load File window. Arrow to the right again, from User Data to My APL, and then right arrow again. Now I'll select the Medium Slug template, since that corresponds to the medium-sized sheet metal template I have mounted on the APL table. When I select this template, it automatically populates some of the relevant information on the Template tab. You can also create your own sheet metal template and a custom grid to go along with it. We'll talk about that a little more later in the video. Now, left arrow back to the Template tab. Let's start defining things. Arrow down to the first line labeled Part Type. And now, let's pause to look at this line here between the image and data entry fields. This line gives you instructions for entering values in the data field you have selected. I'll leave part type set to 0 since I'm using slug type material. If I was using bar stock, I'd of course enter 1 for bar type material. The next line is for part stacking. I'm going to leave this set to 1 as well, since I'm not stacking material. But if you do want to stack parts, here are a few things to remember. The APL can load parts from a stack up to 3 parts high. But there are 2 very important things to watch out for when stacking parts. Number 1, make sure your parts are flat enough not to slide off the stack. And number 2, make sure your parts are clean of oils, grease, or anything sticky that might cause them to cling to each other. Next line. This is where we define the rows on the grid pattern or template. The rows count from front to back as shown on screen. For this program, I'm not going to use all the spaces on the template, so I'll enter 3 here. The next line sets the number of columns in the grid. The columns are counted from left to right. Here, I'll enter 5. Since I'm using the predefined grid that matches the mid-size template, the distance values for the row and column width are already entered. But if I had a custom template that I'd measure the center-to-center distance from row to row and column to column and enter those dimensions in these cells here. Okay, so we are done entering the table grid pattern and part information. Now let's move to the Load Part tab. Here's where we'll define how we load our part. As you move from line to line, you'll notice that the animations here change to show you what actions to perform as you set each value. These animations loop, so if you miss part of it, just keep watching until you see all of it. The first line is OD-ID gripping. The included grippers allow either OD or ID part gripping. I'll enter 0 to OD grip my part. The next line is the gripper number 1 clamp delay. This is the amount of time the grippers will wait after clamping the part before a linear move is initiated or after it's completed. This helps ensure that the part is held properly before moving away from the table. We recommend leaving this at the 2-second default value. Now we get to the part where we begin manually jogging the APL. The APL comes with a remote jog handle, which we'll use to get up close while we're setting pickup points and clearances for loading and unloading. The decals here show us which axis is which. AV controls table motion, AU controls the side-to-side position along the bridge, and AW controls the up and down movement of the ram. I choose the active axis by moving the selector below the jog wheel. And when it's time to grip the part, I actuate the grippers with these buttons here that correspond to gripper number 1 and gripper number 2. All of these controls will quickly become second nature, just like moving the axes on your lathe. If you don't see the AU, AV, and AW axes all on the RGH screen at the same time, then go to the position screen, press Alter, and check the X, Z, AU, AV, and AW boxes. Uncheck any other axis so that only X, Z, AU, AV, and AW will display on the RGH. Okay, time to pick up the part. Start by making sure the AW vertical axis is up high and away from any interference. Next, press Insert on the control or Move on the RGH. This commands the APL to move automatically to the above table position. This saves manual jogging time and gets the grippers close to the initial pickup location. Press the handle jog key to allow the remote jog handle to jog the axes. In a second, I'll select the AU, AV, and AW axes as needed to pick up the first part. But first, I want to verify I've got gripper number 1 facing down. I'll do this by pressing the number 1 button on the RGH or by pressing F3 on the control. Sure enough, the bottom gripper actuates when I press the button. If gripper number 1 isn't in place, jog to a position with plenty of clearance and press the swap button on the RGH or F4 on the control. Okay, Let's pick up the first slug in position number 1. This is always the furthest lower left position. I'll move the 3 axes using the RJH until I have the jaws centered over the part. And in this case, I'll grip about halfway down on the part. This is where you'll need to decide how much of the slug you'll leave hanging out for the chuck jaws to grip. Once I have the gripper positioned where I want it, I'll close the gripper by pressing the number 1 button. Once the part is gripped, you can fine-tune the position in the AU and AV directions. When you are happy with the position, press the record button on the remote jog handle or F2 on the control. Now, let's arrow down to the above door location line. With the part still held in gripper number 1, you can jog away from the table vertically using the AW axis. Remember that you rotate the jog wheel clockwise to raise the ram upwards. Jog a few inches away from the table in the vertical direction and then press Move on the RJH or Insert on the control. This will initiate an automatic move to the above door position. From this position, we'll be jogging the AU and the AW axes to make sure there is clearance for gripper number 1 to come all the way down to the chuck and load the part. Check the picture on the control for a graphic explanation of where the clearance should be. Right now, on this ST15Y, I have all the axes at home, X, Z, and Y. But it looks like I might not have enough clearance. So I'm going to jog the ram down. Sure enough, as I get close, I can see there will be interference between the turret and the rear edge of the ram. So I'm going to move the ram back over the door. Remember, if you're on a small lathe like we have here, Y-axis will almost always need to be retracted to full negative travel. In order to get the clearance I need for the ram, I need to do 3 things. Index the turret to an empty space where no tools are loaded, make sure that X and Z axis are home, and on small lathes like this ST15Y, I need to jog the Y-axis to its maximum negative travel. I will index the turret to an empty spot first. I arrow down to the safe axis location to load line. Here I can index the turret. I press turret forward until I reach an open space with no tools. On the turret, you may need 1 station empty or even up to 3, depending on the tool holders on the turret, the extension of the jaws on the chuck, and so forth. Once I have chosen a proper turret station, I press hand jog and select Y-axis, and I'll move to -2 inches. Then if we haven't done it already, select X-axis and jog it home. Select Z-axis and jog it home. Then press current commands to return to the APL page. Since we just created clearance for the ram, we'll finish setting the values on the safe axes location for load line, and then return to the above door location line after that. Okay, Y-axis is at -2, X and Z-axis are home, and the turret is indexed to an open spot. At this point, I'm sure there is enough clearance to jog gripper number 1 all the way down to the chuck. Let's go back to the previous step, which is above door location, so we can verify the best position for this and then record it. With the door open, I'll select AU and AW and jog each of them to bring the part close to the chuck jaws or collet. Remember to leave at least 1 inch or 25 millimeters clearance between the jaws and the part as AW is descending. This gives room to pull the grippers away from the part and have adequate clearance as the ram moves up and out of the enclosure. Once you've established the desired position along the AU axis, jog the AW axis all the way up to the home position and press record on the remote jog handle or F2 on the control to set the reference position. Now you'll quickly realize that we're adding an extra step here, moving up and down. So once you're familiar with setting these values, you can set your chuck load location first and then come up and set your above door location. The final step on this screen is to record the chuck load location. This means loading the raw stock in gripper number 1 into the chuck. We'll jog the gripper down again until the center of the part reaches the approximate center of the spindle. Now move AU and AW one at a time to adjust where the part is sitting in the jaws or collet, and to set the part concentric to the chuck. To better visualize this, you can open and close the chuck with a foot pedal and adjust as needed. Keep in mind that the part does not need to sit all the way up against the jaws, step, or collet stop. The part program will need to include a spring-loaded tool to reseat the part before starting the machining process. I usually set my part about 1/8 of an inch off the back face of the jaws. When we are done with the chuck load location, we set the reference position by pressing record or F2. Close the chuck on the part with the foot pedal. Now let's open gripper number 1, leaving the raw stock in the chuck. Jog away in AU and then all the way up in AW. Let's close the door so we can start the part machining process. Here, our part program is already made and the program is active. So we'll proceed with turning the part. But we don't have APL mode activated right now, so the APL won't try to load or unload our part, which is good since we haven't finished programming it yet. Now, let's run our part and make some chips. Now that our part is machined, we are ready to retrieve it and return it to the table. I'll open the door and blow everything off. And we can finish this APL setup. Let's arrow over to the Unload Part tab and start answering the questions. On to the first line. I enter 0 again for OD gripping, and I'll leave gripper clamp delay at 2 seconds like before. The third line is also a delay. It's the time from the moment the axis reaches the gripper swap location until the moment it swaps grippers. We also recommend leaving this at the default 3-second value. Next, we'll skip a line down to gripper swap location. We want to make it very clear at this point that special attention is required here to avoid running the grippers into anything when swapping 90 degrees from gripper to gripper. Depending on the machine model, you will have more or less room to do this move. No case is predictable, so it will be necessary to find a good spot for this anywhere along the AW axis. In some cases, it can be done right in front of the chuck, and in other cases, it needs to be done mid-level above the chuck. In our case here, it looks like there is sufficient clearance right in front of the chuck, so I'll press the swap key a couple times to make sure the grippers don't hit anything. Also make sure to leave gripper number 2 in the horizontal position, ready to unload the part from the chuck. Once you are comfortable with your swap location, press record or F2 to set the position. Now let's go back to chuck pickup location. For this step, we'll unload the machine part from the chuck with gripper number 2. First, I'll press the number 2 key to make sure gripper number 2 is unclamped. Let's jog the gripper in small increments, up or down, using the AW axis. Keep going until the center of the grippers reaches the center of the spindle approximately. Moving both AU and AW, one at a time, fine adjust until the gripper is sitting as deep as desired over the part, and both the part and the chuck are concentric. To better visualize this, you can open and close the gripper number 2 and adjust as needed. When you're ready, record this reference position by pressing record or F2. Now we're ready to leave the enclosure and drop off our part. Arrow down to the table drop-off location line. Make sure the gripper number 2 is holding the part and open the chuck by using the foot pedal. Jog the part away from the chuck using the AU axis until the part clears the chuck. Then jog AW all the way up to home position. Now you can push move on the RJH or insert on the pendant to move the APL automatically back to the table and swap the grippers. The result of these moves will get you right above the table with gripper number 2 and the part in the vertical position ready above the table drop-off location. Slowly jog the AW, AU, and AV axes in order to bring the part down and locate it just above the template pocket, ready for drop-off. The drop-off pocket is the same one where you picked up the part earlier. We recommend dropping the part off at about 60 thou or 1 to 2 millimeters above the table. We've reached our drop-off location, so we'll set this position by pressing record on the RJH or F2 on the control. With that set, I'll unclamp the part by pressing number 2. Now I'll move AW upwards to mid-level. Now the last line in the tab is the chuck clamp delay time. This is the time the arm pauses after gripper number 2 has clamped the part before the APL arm moves. We recommend also leaving this at the default value of 2 seconds. Now let's move to the final tab we'll complete before running our job, the Run Job tab. The first 2 lines will provide information after the APL is running. The first line tells you what part is currently being loaded or is already in the machine. The second line tells you what part is in queue ready to be processed after the current part. The third line tells you how many parts are completed and on the table. There is a visual aid shown on the right side of the screen, and it is defined by the template description we did on the template page. The current part is shown in yellow, and the completed parts are shown in green. The fourth line provides a part count limit. Here you can input the total quantity of parts you want to run. You can input a value that is less than the amount of parts on the table. The APL will stop processing parts once this amount is reached. You can also choose a value that exceeds the number of parts that fit on the table. The APL will stop for a table reload once all the parts in the table are processed, but it will keep counting parts until the total amount is reached, even if it takes multiple table loads. The next line is a rapid speed override. This rapid override applies only to APL motion. It is designed as a precaution to use when preparing a setup or for loading and unloading heavier parts. We recommend doing the first couple of parts anywhere from 5% to 25% to be sure all is set correctly. Next is a slow rapid distance. Basically, this slows down arm motion before reaching the table or chuck for part pickup or drop-off. We recommend 3 inches or 75 millimeters as a good starting value. The next line is the speed that it will slow down to. This speed really is application dependent. If you want the grippers to approach the table or chuck with caution, we recommend a value between 25% and 50%. The final line is a display that cannot be modified. This displays the current status of the APL and describes each step as it is being performed. Now that we have our APL job set up, let's look at how APL programs are saved to memory, loaded from memory, and how to start a new job. We'll also explain what APL mode is and how it works in conjunction with the part program. We will start with the buttons at the bottom of the screen in order from left to right. The Insert button is used to turn APL mode on or off. When APL mode is on, it activates all APL motion as programmed. Switching to APL mode also serves as a quick way to save the current APL program being worked on. When an APL program is not saved, the program name on the top of the screen is displayed in red text. When the program has been saved, it is displayed on top of the screen in black text. The naming of programs is limited to the display space, and it is not case sensitive. The F2 New Job key is used to clear all the information from the APL tabs to start over. Be cautious when using this button, since it will erase all the values you currently have entered unless you've already saved them by pushing F3. The F3 key is used to save the APL program that is currently being created. Press the F3 key, and this will bring up a directory. Use the cursor up or down arrow keys to navigate to the user data folder. Arrow left to enter the folder, highlight the My APL folder, and arrow to the left to open it. Now enter your APL program name before saving it. If you don't enter a program name, the control will default the name to apljob.xml. Anytime you want to save a modified program or newly created program, you must enter the program name. The names must match or it will be saved as a different program. We recommend saving the APL program with a name similar to the part program name, so you'll know what part the APL program should be loading and unloading. You can also save pictures of the grippers and jaws for future use, and even use M130 in your part program to easily view these pictures. The F4 key is used to load an existing APL program from the My APL directory. Press the F4 key and navigate to the My APL folder found inside the user data folder. Highlight the program you want to load and press Enter. This will load the 4 APL setup tabs with the appropriate information. Also, for the APL to run in a loop until all parts are done, the part program must have an M299 at the end instead of an M30. If APL mode is turned off, the control reads the M299 the same as an M30. There are more details about these M codes in the operator's manual if needed. Again, keep in mind APL mode must be activated for the APL to function automatically. Select the part program for the parts you'll be loading, then select the APL program that corresponds to that part program, and then press Insert to activate APL mode, and you're ready to start. As we mentioned earlier, you can create custom sheet metal templates and grid patterns to go along with them. Here are 3 things to consider if you do want to make your own grid. First, allow adequate space between rows and columns for gripper clearance. Number 2, all rows must have equal spacing. And number 3, all columns must also have equal spacing, but it can be different than the row spacing. With all that we've covered here, we hope you'll be up to speed using your APL right away and enjoying the benefits of your newest operator. That's all for now. Thanks for watching.